And I just want to hand the stage over to Fabio and Stack. Welcome.
Yay! Good times. I hope you guys are excited because we are. So, hi, my name is Stack. This is Fabio. We are from TrueSec, and this is Gone in 45 Minutes, War Stories from Incident Response.
Yes. So this is going to be kind of a story-driven like session, which is not really my style, but I'm going to try something new. It's his style, but I'm embracing it.
Yep.
I'm more of like the demo on the keyboard type of presentation, but we're going to go through some parts of some incident response cases we've handled over the last year or so, and we're going to do it kind of like zooming in sometimes into some of the more interesting technical details and kind of jump a bit back and forth, try to give a little bit of taste of different things, and also keep in mind the tricks and stuff we're going to show. It's, if you plan for these things beforehand, there are much better ways to do these things. But, when you do forensics, it's a lot of figuring things out with the data you have, which is really incomplete and crappy data. So there's some tricks about that, so keep that in mind. It's not like the state-of-the-art solutions here. It's working with what we got, all right? Take it away.
And instead of just doing the typical kind of boring who am I intro thing, I'm actually interested about you. So let me see a little bit of raise of hands here on how many of you has at some time in your life worked as a sysadmin? Somebody that takes care of the computers and the network and that kind of stuff. Sweet, there's actually a bunch of you. I'm happy for that. And then the other question I only have two, is that has any of you in here ever worked as a technical manager? The ones that's actually responsible for the whole network and the system and everything, and probably as a squad of people. I see a bunch of them, cool. The rest of you that hasn't worked as a technical manager, well, here's your chance, because let's imagine for a second that you are the technical manager of a multinational manufacturing company, and this is your office. That place where you used to go to before the pandemic and do the work thing? But now you're home in your bed and you're sleeping and it's all sound and safe, but somewhere around 4 o'clock in the morning, you're getting a little bit of a rude awakening when your phone vibrates quite aggressively on your nightstand. The first thought that goes through your head is obviously, what kind of idiot is calling you in the middle of the night? But then you pick up the phone and you realize it's actually the production manager on one of your company's factories in Indonesia. So you pick up the phone. Hello? Okay. What do you mean everything is down? Okay, so you can't write your shipping orders and nothing works? Calm down. It's probably some network interference. Have you tried restarting your computer? At this stage, you apparently hear the stress from the production manager on the other end, and you promise to look into it. So you look at your phone and see if there's any new alert emails there. There's actually no new emails, so you scooch over to your laptop, right? And decide to get on your Rdp jump box to dig in to see whatever goes on. But you're getting greeted with this message that the remote desktop gateway is currently unavailable. Start to think a bit, and then your phone vibrates again, and you realize that you have a couple of missed messages from Phil, one of the senior engineers down at the office, and he seems a little bit distressed. So you find yourself in your car, like half dressed, right? Driving all the way down to the office, and your mind is thinking about, is it one of those SON switches that's got the badat again? Or is it the MPLS connection to the data center that's acting up like it did last time? Once again, you're getting distracted by your phone vibrating, and eventually you reach the parking lot, and your phone is now running hot from all the incoming calls that you get from people asking what's going on and demanding answers. But all you have is more questions. You slam the door shut, have your half-drinking coffee, right? And you're running over the parking lot, up the stairs, through the reception, waving at the security guard Dave there, and eventually reaches Phil's office. standing to take a breath for a while, that's when he tells you that all the VMs that you have in productions are down. And actually, on each and every of the cluster servers, you have a nice little text file on the desktop that contains a ransom note. Then it suddenly dawns on you. That production manager in Indonesia was actually right. Everything, and I mean everything, is down.
Not a great place to be, isn't it? And yeah, we face compromised networks. You know, we do incident response, and we meet people that have just experienced in this. And it's a type of situation where, you know, it's easier to let your instincts take over, and you know, you may just want to like run around and just unplug everything, shut everything down. But that's something that ideally you shouldn't do, because what you're experiencing now is basically like a crime scene. You should, and I know it's hard. You know, I'm there next to who just did it, and I know it's hard. But try not to touch anything in those situations, because most likely you're going to destroy some evidence. And then when we do our investigation to try and figure out what happened, how to clean it, and all that stuff, it's actually going to be harder. It's going to take longer. The investigation is going to be less accurate, which means it's going to be harder to take the right decisions, which ultimately is really what you want to do. You want to take the right decisions. But doing a thorough investigation takes time, right? You want to do it right. Because, you know, when we do investigations, we obviously get questions all the time from the customer side, like, when can we do this? You know, can we connect the system to internet now? Is it safe to do this? Is it safe to do that? And we're in the middle of the investigation, and we don't know yet. We just don't have those answers yet. And we will maybe not have 100% accurate answers anyways, but at some point we'll have to have something. But we need some more time, and they don't really have time because their business is down, and they're probably losing millions by the hour. Mm-hmm. And, you know, we're going to have to figure something out sooner or later that needs to be accurate enough. And that's tricky. How do you figure out exactly when it's a good time that you feel confident enough that you've looked at things and you understand them? Because too many times, things don't really look the way they are, right?
Like this instance, for example. Customer calls us in and says, we have some kind of virus alert going on one of the servers. Can you check it out? We check it out. Mimikatz. So we realized that, okay, so Mimikatz is being run on this server, and we trace it back, and it shows up, and it actually shows that it's originating from another box that's have RDP exposed to the internet. And there's no shaming that. I mean, I for sure has put port 389 in a RDP server on the internet at some time in my life, right? But at this stage, apparently there's about 11,400 something in Sweden that continuously do that. And that's all good. And it's like,
not really, but.
Not really, but in 73 of those also, you know, they, instead of just doing that normal kind of thing, they switch one port number. So 3388, 3389, that's not really going to save you, but hey, good riddance anyway, right? So we were digging into this a little bit further because you can't just leave it there, and we realized that on another server, there was a local admin user added. So at this stage, we're having Mimikatz credential extracted. We're having this server that has a local user added to it, and it all came from one RDP server that was connected to the internet. So it's time to talk to the customer, inform them. So we say, okay, we have 3 IOCs, and we want to keep digging. And the customer's like, okay, sweet, but we just clean those, right? And then we can close the incident, and it's all business as usual. Well, it's not really business as usual that, because if you see that if an attacker breaks stealth to the level where they say, fuck it, we're going to run Mimikatz on this box, they got quite far into their operation. So either that or somebody, an admin, has forgot all the passwords of all the users and figured that that was a good way to extract it. So this is where the investigation begins. And what we didn't know at that time, and we're lucky about that, is that at that current time and space, this was actually what's going on. full domain compromise, multiple backdoors, multiple C2 channels, over hundreds of systems were compromised, and sensitive files had already been extracted over FTP. And it was a virus alert.
Yeah, that's what I mean by doing a thorough investigation, because, when do you stop? When do you feel like you've found enough? And it's hard to tell sometimes, because you never know beforehand if you're facing some, like a lonely script kiddie that is watching some tutorial on YouTube how to run SQL map and Mimikatz, or if you actually are up against a nation-state group, right? Or just some very cold guy up there. But talking about nation-state, it is particularly important. And of course, you don't know beforehand, right, if you're facing those or not. But we've done enough of those to know that you will figure that out eventually when you dig enough. And this is a good example of something that might look just a phishing attack, but it's actually something a bit more sophisticated if you look a little bit under the surface. And it's a case we investigated earlier this year where the initial access vector was phishing, right? Obviously nothing new. And they used RDF attachments as a payload delivery mechanism, which also is nothing new. But they were doing a couple of things that were particularly interesting, so we'll go through that.
So typical scenario, normal one, user gets phish email with some kind of blah, 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 you need to open this, and then there's a document in there. In this case, it was something that named .doc, but it was actually a RTF file, and RTF is a rich text format created by Microsoft in the vintage years, and it's pretty text-based, it's easy to just reverse and look through, but what's interesting about it is that since you're loading in the document, but it's actually an RTF file, Word will open it up and treat it the way that the RTF specifications works, and those include something really interesting called templates. Yes.
So we open it up, the attachment, it looks something like this. And that's kind of like, it's a punch in your eye. You can't miss it, right? It says template and then a URL, which really sticks out. Now, of course, it's a zoom in to a small part of it, but still, you go through it and you kind of see this, right? So you want to go and check. I mean, I guess we have a feeling for what a template is, but you go and check the specs and it says, well, the template is something that takes an argument that is a name of a related template file. The argument we had there was a URL, right? So this says you can take a name, which I guess you would expect a file name or maybe a path to a local file. Apparently, you can give it a URL too. That happens a lot, right? Sometimes,
it does.
Too often when you do, living off the land deliveries in Windows, you can specify a name of a file. You can also give it a UNC path or a URL. Many times, whatever is doing that is very nice to you and go and fetch it for you, right? They're also usually proxy aware, which is very nice when you build custom malware, because then you're sure that you're going to hit the right configuration. Anyways, that's what happened here. You had the template fetching out, a template. It's supposed to be a template anyway. It was triggering Word to make this connection to the attacker control server and putting that into the document.
And this is where it gets a little bit more interesting. In the beginning, not that cool. But here, if you were accessing that image.yagh file using a browser or curl or wget, whatever, you wouldn't get any connection. Nothing happened. But if you use the user agent of Word, then suddenly, voila, the payload gets delivered. So, and then it all turns back to this boring thing again, like super lame, enable this to view content. Typical kind of phishing-looking style. And I think that's by purpose, because if you can do that, that's probably if an analyst looks at it and they send it in, this is a phishing email, somebody looks at it, they're going to say, oh yeah, it's just a phishing email. Report it, and it's all good. And they kind of staying under the radar for what the real campaign is going on, because if it was really sophisticated, it might just pique a little bit of interest to dig into it. So when the user enables that, this is the funny part, and this is where they really played the game up. now it turned into social engineering, because a couple of weeks ago earlier, they already stolen internal documents. And as soon as you enable that template, that's a docm file. That's a fully macro-enabled Word document that then populates inside that Word RTF file that you open up, and it contains stolen information from that organization. So the user will get that feeling, oh, I did the right thing. This is my company stuff. This is what it looks like. But in the background, the macro executes and all the bad stuff just happens.
Yeah, and that's the bad stuff.
Oops.
One more. Dude, let's decide who's
Battle of this.
We're all right, cool. So that's the macro. It was not really anything too fancy in terms of how you execute stuff. It's a macro. I guess a lot of people have seen a lot of those. So what it did is it created a directory under C program data wc_proxy, and then it drops, well, it fetched and dropped a couple of more files, one exe and one DLL. And they were named them wc_proxy.exe and wc.dll. They put those in the directory they just created, and then there's some delay, usually to avoid the scans, right? And then it starts the binary. And, well, if you see that kind of, if you look into this a bit, it kind of smells immediately like Dll Side Loading. If you haven't heard of Dll Side Loading, this is a 30-second version of how it works. You take a binary that is a legitimate binary, and preferably signed, right? Like the one here, the wc_proxy.exe, that was a signed binary that you have up there on the left, signed by Avast software. That is part of the Avast antivirus. Not blaming Avast or anything. There is DLL side loading issues all over the freaking place. But anyway, you take a binary that is legitimate, and when you run it, it's most likely going to look for some additional libraries and stuff to load, right? And it's going to be a sequence of places that it looks for where to load those libraries. It's going to look first if it's already loaded, obviously, if it's defined as a known DLL in the registry, or if the application manifest specifies where to load it specifically. Then it's going to look into the directory where the binary was started from. Right? And remember, they put those two files together next to each other, and then they start the binary. It's going to go down all the way through this chain, and eventually it's going to look for that DLL that is named that way. That's where the attacker code is loaded. But it's loaded by the legitimate software, right? By the legitimate binary. So if this is going to do like, connect into a command and control server or start doing something bad, if you look at what process is doing it, it's a signed binary by Avast that is doing that. So, and it's kind of ironic that they often choose antiviruses when they do this type of stuff. And Chinese actors love DLL side loading. I don't know how many examples we've seen of DLL side loading of all kinds of things. And I can only imagine, every time we see a different one, I get in my head the picture of the huge database that they must have. Like, okay, what DLL side loading you want to do today? You want to pick Avast, you want to pick Google, you want to pick any of the million Windows components that are vulnerable to this. So it would be nice to have that database, I guess, for red teams. But it's really not easy, or it's really not hard to find, to be honest. So, but from there, you start kind of the whole post-exploitation stuff, right? We're not going to go into that now for this incident, but there were a few sneaky things about this, right? If we try and recap from the beginning, there was that attachment. And remember, the macro was never in the attachment, right? So already there, whatever email filtering thing that you have in front is going to have a pretty hard time because there is no macro. They might look into, even assuming that they're going to look into the attachment and find the URL, which I think is unlikely, but either that or something down the line where some component does a prefetch. Remember the user agent thing. You have to use the Office user agent, Microsoft Word user agent, to be able to even get the second stage. So if you have a prefetch filtering, that's also not going to, unless they spoof Office, but yeah, it's a bit unlikely. What do I have more? Yeah, we had the fact that when you run the macro, you actually get real content that was stolen from that company before. So that's another layer, right? It's less likely for the user to actually report it after they fall for it, which is exactly what you want to do, right?
And it looked totally lame.
Yeah, and it looked totally lame. So if someone sees it's probably, it's just another phishing. Put it down, the pile of phishing someday we'll check, we'll never do. And of course, DLL side loading, which is nothing new, but it's another extra thing to kind of avoid detection. So, given all this, You can, of course, like if we start thinking of how would you detect something like this, having the right tooling, ideally. And you can, of course, looking for this specific attachment that they sent. You get a hash of that, and you search if you see that hash anywhere. Or you have a sender address of that email. You can search for any emails received from there. You have maybe the file name. If it's specific enough, you can maybe search for that. But if you have tooling that allows you to do a bit of more advanced queries, and in this example, our customers were using Microsoft solutions, so they were on like Defender of 365 and all the Defender suite of things. They also had an EDR, so we use that. Any other solution that allows you to do the same thing will probably work just as well. It's the idea. We basically did a query like this, because you can look into the email stuff from here, and you can do like, can you give me all the attachment information where the attachment type is RDF, but the file name doesn't end with .rtf, which is what they did, right? It was an RTF file, but it was named .doc. And it turns out this doesn't give false positives at all. Okay, very few maybe, but totally feasible to go through and figure out the false positives. And it was a great way to find more variations of the different phishing waves they used in that campaign, because it was a very time-long extended campaign. Again, it's a nation-state campaign, right? So they have variations and stuff. But they like this technique with RTF files named .doc, so they kept doing that. And if you have the luxury of also having an EDR on top of that, which we did. So this is not the case I said at the beginning where you have to work with crappy data. This is actually awesome when you do forensics. This is exactly what you want. But if you do have an EDR, you can actually take a step further and say, I want to get all those suspicious attachments that have that type of characteristics. So they are RTF, but not named RTF. And I want to search in all the device file events if any system has ever seen or touched any of those suspicious files. And you're going to get a nice list of which devices and which process touched that file. And in that case, that actually allowed us to find a few more compromised systems because it came from another source. So they were also doing internal phishing because they were after specific people in that organization. So when they had control of already compromised mailboxes, they would also send emails from that compromised mailbox to other people inside the organization. So the source would be an internal source. So we found those emails this way, and then we realized they were doing that too.
Sneaky, sneaky.
Yeah. So to wrap this up, it's basically the idea of trying and abstract the detection queries and hunting when you have the tooling and the possibility to do that. Because looking for hashes and specific things is great and should definitely be there, but when you can, and when it's feasible to abstract that to a little bit higher level, if you find the technique instead of specific IOCs, that usually takes you a step further, and especially when it's this advanced campaigns, it can really pay off.
But you don't always have that luxury, though. Because not everyone has that EDR installed and all that. So how do you do if you want to track or find some persistence on the system, specifically in services, and you want to do that at scale, because it's a tedious work to go through all the services. So let's imagine for a second, let's play around with this incident. You are now currently an incident responder, and you've been tasked by the quest to identify if there's any weird services going on. So the day of the breach was the 12th of August, right? And first, okay, you can go through the event log and see if there's any funny stuff there, but it's not always that you have the possibility to find event logs, because they can either be cleared like this, or they can have just been rotated, right? So what you normally would do is to see whatever kind of systems have been started on the system. So you can use auto runs for that. And you probably sort by time date and see if there's that date there. But your date is not showing up. But you find this weird service called help SVC, right? And if you look at it, publisher's not verified. And the image patch looks kind of weird. It's helpsvc.cc9. But the timestamp has nothing to do with the kind of time that you're looking for. What's really interesting with this service, though, because this is a bad service, and if you weren't using autoruns but using services.msc instead, you see this. It wouldn't look shady at all, because it would be SVC host calling for it, and it would look normal. Same thing would be if you use the get WMI object to see if you can find some more data. Same thing there. Nothing sticks out. So we kind of need to rely on using tools like autoruns. And the .cc9 one, that kind of hurt me a bit. So you need to search for that. What is .cc9? And it's not a valid file extension. But what it is a Chinese iPhone killer phone.
Which doesn't really help. So if you dig a bit more, you do this a bit more to scale, you can use the command line version of autoruns, run it across multiple systems, build a nice timeline. If we zoom into that particular service we're looking into, we get like the hash, for example. Throw that hash in VirusTotal, and there is no match. Which is weird, right? Whether it's legitimate or not. I mean, if it's known bad, it should be there. If it's known good, it should also be there, because it should look something like this, right? Especially because the service is posing as a Microsoft service. You would expect it to load Windows components distributed by Microsoft, which is what VirusTotal would tell you, I'm guessing. So just the fact, I mean, you can do more research, but just the fact that it's just not there, it's empty, it just doesn't feel right. But the timestamp doesn't really match, right? Remember the timestamp that Autoruns gave you here? It's 2019-1207. It's not what we're looking for. And where does Autoruns get that from, you know? Well, it turns out it's the last write time attribute of the help svc.cc9 file, which is loaded by the service. Which is fine, it makes sense, right? But that's just one attribute, right? There are 3 timestamps on a file in Windows. You have creation time, last write time, and last access time. And if you check the creation time of that file, that is actually the interesting date for us. So that was interesting. If we fast forward a little bit, and we'll actually show you the exact commands that the threat actor used to install that persistent malicious service. This is exactly what they did. They create a service and they point the SVC host as a network service. They give it a name, and then they set a registry key under that service that says service DLL, and then the path to the help svc.cc9 file, which is just a little bit clever way than just pointing your service to your malware. You point to SVC host, and then you instruct SVC host to load that when it runs. Kind of feels like a Dll side loading in a way, right? You just use a legitimate process to do your bad stuff. Yeah, then you give a description and then some settings for what to do when it fails. And then you have a PowerShell one-liner down there that takes the last write time of your malicious.cc9 file, and it sets it to the last write time of a legitimate DLL in the System32 directory. That's time stomping, right? You change the time of stuff. It's time stomping. Obviously, very easy to do, right? Now, they could have done the same for changing the creation time and the last access time. I don't know what they did. I didn't write this. But, I mean, I would have changed all 3. But to be honest, that's what Autoruns gives you anyways, right? That's what we saw. We had to manually look into the creation time of that file to figure out, you know, that something wasn't really matching. So then we started thinking, how many other timestamps could be of interest when we want to narrow down some service installation events to a specific date, other than these 3 that we're looking at now. So we wrote a tool. We wrote a tool that goes through the registry and grabs everything basically on the services. This is something on GitHub. I'm going to put the link there in a second. It basically, you can run it on a system, and then you can get a result that looks kind of like this. You're going to get, I mean, you can just output it in JSON if you like. And this is just a zoom in to the help SVC service we were looking at. You have like information about the service itself, and then you have like a couple of main sections. You have the command line details. That's what the service points to, right? That's the SVC host, and the 3 timestamps of svc host.exe, which in our case were not very interesting because that was the legitimate one. But if you have a service that actually points directly to a malicious file, then those will be the 3 timestamps of that malicious file. The other part is the actual service DLL path, right? The one that is loaded at runtime by the service when it starts. And the 3 timestamps of that file as well. Now, in our case, one of those was time-stomped, the other two weren't. So we were actually good enough at that. In a particular case, we were good enough with this. There's one extra time step that we can use, because when you create a service, that is created in the registry, right? And it creates a key under services. And registry keys have timestamps too. So you can actually check the last write time of the registry key in the registry, right? So you don't have to rely on files directly. And it's not that common to timestamp this one. Might be possible, maybe. Maybe Stuck will tell you in a second. But it's not that common to do anyways. And that tool also gives you, if you want, a nice timeline that kind of looks like this. So you can actually run it across a lot of systems and then build a time and zoom into the interesting point in time. And then you see if you're looking at the image path creation time or a registry key last write time. So that kind of helps identify that. It's going to be a very long timeline. But if you have a specific point in time, then you can zoom in there. And the tool is on GitHub. We put it there last night.
Yeah. Forced Alex. Put it on the Git. We're going to talk tomorrow.
No, but really, it's something that we worked up until last night to make additional improvements, and now it's out there. So hopefully it will help in figuring out at least services in terms of potentially time-stamped services. And there is a lot of other persistence, of course. One thing at a time, okay? No, but really, it helped. So we think it could help you guys too if you're doing a response or an investigation.
Okay, so Fabio talked about that registry key. Well, apparently that's not really exposed to PowerShell by itself, so you can't use, well, you can talk to the API and talk to it, but it's not really that easy and tricky. But this homie here, the guy in the middle with the ukulele, he actually put a pretty smart C# PowerShell thing that he built. His name is up there. He used to live in China. His friends gave him a Chinese name. I'm not going to even try to butcher it, so you need to check him out. But if you take that script line and you smash that puppy into PowerShell, you can change this timeline here, so you can set the date time to whatever time that you like, which is particularly something that's good on the system, and then you'll set it to whatever key that you want to timestamp in that reg key. So make sure, red teamers, that you stomp all your keys, because you want to stay sneaking underneath the radar. And don't tell any of the attackers about this, because that would be a problem for us. But as you can see here, you run it, boom, it updates directly, and it's all nice and shiny. But if you went through all that process of just being all ultra sneaky, you time-stamped everything, you cover your tracks, and then you decide to live off the land a bit, and why not use RDP while you're at it? So you have this compromised system, and it's time to move on, so you open up Microsoft Terminal Services, because you're going to jump box into the next box and see whatever goes on that system. That's a good thing, but you will be leaving trails behind.
You will. And it's, you can debate whether using RDP to jump around is good or not. I guess there are goods and bads. I mean, that's what the admins do, right? So what better way do you have to kind of hide in plain sight than using exactly what the admins use? So that's a pro, I guess, if you look at it that way. Or maybe you just don't know how to run command line tools, and then you have to use RDP. Whatever reason, you're going to leave some traces behind. And we're talking here about the case where you run an RDP client session from a system that you have already compromised. Right? So say you jump on that RDP exposed system, and then from there you RDP somewhere else. That middle jump server, I guess, is now called, that will leave some trace from an RDP client side, right? Which lives here in your appdata local directory for the user you're using currently to start the mstsclo.exe process. It will leave some files here. As soon as you establish that connection and you have a visual desktop in front of you for the remote system, locally, it's going to cache this stuff, and that's basically cached images of the screen. And that's simply there to,
Reduce bandwidth.
Thank you. Reduce bandwidth, right? So you avoid sending those images back and forth. If it's the same image, you have it cached, fine, you just grab it locally. It's not readable in terms of you can just open it up in an image viewer. It's not going to work. It's binary stuff. But smart people have written tools, and you can run like this one, BMC tools. You're going to give it just a path where those files are, and it's going to spit out, for an average session, still like thousands and thousands of very, very small images without really an order. And then it also has the option to create a nice, like, all stitched together type of image. So you're going to get something that looks like this, which is blurred on purpose, but it's usually like a, I don't know, 100, 200 megabytes file that you can really zoom into the details. But it's not ordered.
It's chaos.
It's a bit of a mess. There is some kind of ordering. It goes kind of like from top right to left and then up. But it also depends how you move your mouse. I don't know. So there's no real like way. I guess it's a proprietary algorithm. It's part of Windows, right? Part of the MSTSC client itself in figuring out how to store it and how to actually reuse it for reducing the bandwidth. I don't know. I leave that to someone else to reverse and figure out. But anyway, you get stuff like this. And then you zoom in, and you try to figure out what they did. So we'll take a case where this actually helped us a lot. Because you don't always have logs, right? You don't always have a nice CM where you can actually do your query, and you don't have whatever, things happen, so, or not happen. But in that case, we didn't have so much logs. We didn't have so many artifacts left on disk, so we had to rely on this type of stuff. And we zoomed in a little bit, and we saw stuff like this, which, again, it's all unordered and stuff. But to the keen eye, this is kind of showing that they probably did this, right? That's what it looks like. It looks like Mimikatz. There are some pieces there, like the stars for the output file. The yellow part is stuff we redacted because it's a real image. Yeah, you can kind of feel that, yeah, they probably ran Mimikatz.
Yeah.
You don't know where, because this is just showing you what the remote desktop client was showing on screen.
For that user, though.
For that user, yes. You don't know what system that you can correlate with other logs. And you don't know even if they manually wrote that output in the command line or if it's actually executed. Very likely they executed, right? But there's nothing telling you that. So it's not really a log, right? We'll get to that. Then we find stuff like this. There in the middle, you kind of have it straight away. It says Hydra and then some commands. So, the network brute forcer, Hydra. They ran it. You can see some targets.txt. You can see in the command line, you can see some parts of the output file. You can see they use some other text files and I guess some word list or whatever. Then you other stuff like this, which I was a little bit unfamiliar with this when I found it, but it's a freeware that is called Web Browser Pass View. Apparently, you can just run it and it extracts like passwords and cookies and stuff from web browsers. But it was kind of interesting because this is in a specific user's cache, right? And that user happened to already be a domain administrator in that case. So why would they do additional Mimikatz and network-based brute forcing against other services and extracting passwords from browsers when they already have a domain administrator account? They're RDPing with it. And, well, this was a ransomware case, so-called big game hunting, right? It's a new, I guess not new anymore. It's been a while now. But what they normally do in those types of campaign or attacks, I guess, they not only take over the whole Active Directory, but then they go after very specific things like hypervisors, which are not necessarily domain joined, right? That's what we found next in that picture. That's the Hyper-V VMM, and that's a VMware vSphere client. So obviously, we're going for hypervisor. Why would you go for hypervisors? Well, it's nice to find. It's an easy way to go to interesting systems. It's probably something named backup, right? Because backups are interesting. You want to wipe the then there's actually ransomware that either manually or as part of the ransomware, they shut down all the VMs, and then they run the ransomware on the host. So it's going to encrypt the virtual disk files from the host, which is nasty to go through because nothing starts, obviously. So that's a painful investigation. And of course, backup folders.
And it's nice to steal creds using, if the admins be using that computer, logging into the support for the backup system, using those credentials, then you have those there. So go crazy. That's nice. But I actually didn't know about this Rdp cache until I was digging into and doing incidents and stuff. But just like this guy over here, I'm into puzzles. So it's really intriguing to go through those and just look at that stuff and just have that vibe. But it's a mess, and they're really hard to figure out. But some smart people out there developed this tool called Rdp Cache Stitcher. So you can, Friday night, nice whiskey, drag images. So I'm hoping that some of you AI developer big brains out here tonight can help Stöck out a bit and maybe create the AI tool that will do this thing for me so I can focus on only having the drinks instead.
Or reverse the algorithm that the program uses to store it, then it's probably easier to walk it back.
Yeah, we can do that. But like Fabio said, this is not a real science, it's not a real log system. We can't rely on that because we need to verify all the things that happen. They could open up a folder but not do anything there. But if they move around the system, they will eventually leave more traces, and that's called shellbags.
Yeah, it's one of them at least, which is particularly interesting in this case because, again, you're RDPing into a remote system, right? So that is another compromised system. On that system, you're RDPing, you have a nice UI, GUI, so you're probably going to browse around stuff, right? You're probably going to use Windows Explorer, this one, to browse around directories and files. Now, Explorer has a nice feature that, if you resize a window or sort by date or whatever, that stuff is going to be remembered next time you open that directory or file or whatever, right? If you have big or small icons, whatever. That stuff is stored somewhere, and it's stored in the registry. It's stored here. These are called shellbags, which is particularly interesting because you can actually reconstruct a little bit of a timeline from there. It's not something you can just read out the box. You need tools. Eric Zimmerman, among his great tools, he also has a Shellbag Explorer, which has a command line tool version of it. You use it down there. You could just point it to the place where you have the hives of the registry hives of the user you wanna look into, and it's gonna spit out a really nice CSV for you that looks like this. It's gonna tell you which directory was part of that shellbag and the timestamp on it, which is very interesting, right? Then you know that within that interactive session, the user had that directory open to do whatever. So if you correlate, for example, with the client side of the RDP, with those images, if you figure okay, they were probably in a folder called backup. You could go in the remote system, check the shellbags, and you also have the timestamp of when they were in that folder. And then you have some parts of the picture too. So you put it together. And it's also nice because it's going to show you the UNC path. If you go to a network share from Explorer, it's going to show up here as well. And also external drives, if you put it in a computer or external backup disk, whatever, it's going to show up there as an external drive as well. So it's very helpful. And it's all good when we figure out when we want to figure out what they did, right?
Yeah.
But sometimes we want to be a bit, want to try and take a step further and try to figure out maybe what they're going to do. Because what best way is there if you already know what your opponent is going to do, right?
Yeah, absolutely. And remember this one. You remember the Chinese state sponsor kind of payload thing that we had in the beginning? That was the first stage of that RDP or RTF phishing email. We figured that these guys were continuously just making new phishing campaigns over and over again, and they were just it's a bit of a hassle to just be against somebody that has unlimited resources and manpower, kind of. So we needed to find out if there was a way for us to actually stay ahead of the curve to help this customer out before it went totally out of hand. So if we look into this domain, we're going to see if we find something funky about it. So, of course, classic Hoey's. What do we found? Well, it's registered on the 19th of January, so that's okay. And the register of this is named Silo. Quick checkout on the transparency log over at crt.sa. It shows that on the 19th as well. Yeah, of course, they got a little bit of a certificate on it, but we don't really know what they did after that. We just know that they got a certificate. So you could use tools like security trails for this because they store a lot of data and they have something called historical DNS records, which is pretty cool. So if we smash in favorita.bus here, we see that it came up on the radar on the 20th for security trails. And it's running there for 21 days. It's hosting itself in Choppa, who knows what they had there. But then it goes to 127.0.0.1, and it stays there for 9 days. Then it comes back again. Same IP, same good old Choppa domain, stays there for 4 days until it eventually goes to 127.0.0.1 and is gone until the present day. Interesting. So when we check out that 127.0.0.1, you can ask yourself, why would anyone like to host their domain with an internal localhost IP address? Well, they could be playing around and trying to get people to own themselves. That's obviously a good reason for it. But when 2.2 million records have that, there's got to be some kind of reason. Maybe it's for, I don't know, maybe it is that that would become something later. Maybe some of these domains might just be kill switches or even sinkholes. Because if you're running a malware on a system and you want it to stop talking to the internet, what is better than making a DNS request to localhost and it's just going to keep on talking until you refresh the DNS and voila, it goes out again. So we kind of figured that that was going on. Later at this stage, we realized that we got another IOC from their C2 channel. That's the other part of the malware that was kicking off. And that domain was this one, the msft.ncsi, and it was registered in November. The well-trained eye here, we see that it's extremely similar to the official Microsoft one called msft.ncsi. That's the one without the dash that's been around since 2005. And that's actually the domain that any Windows 10 box will try to access to see if they have connection to the internet. So you can expect a lot of those requests in your systems. So it was a pretty sneaky stuff. Okay, could we find any similarities? We looked into this as well. It started its life in November back at Cloudflare. Then it moved around, so it stayed for about 3 months over at DigitalOcean. Then it sinkholed for a couple of days. Interesting. And then it came back on Linode. So if we look at that a bit further, we'll see that both domains were registered using name Silo. So at least we know they have a preference of using a defined registrar, right? And thinking out of a business perspective, if your organization says, we're only using name Silo because that's what we have decided, that's kind of how Chinese state sponsors work. They are very organized in certain, maybe they have even a handling on that, who knows? So when we look at these two IP addresses, we can see here that both go offline for exactly the same period, for exactly the same amount of days. I don't think that has nothing to do with the Big Lantern Festival, which is a part of the Chinese New Year, but in theory it could, right? So what's interesting though is that favorita.bus, the first day's payload never comes back again, but the C2 channel makes a jump and moves closer to the customer in a Linode section instead of the more, the more dirty droplet over at DigitalOcean. So here we are thinking that, okay, name Silo, sinkholing, they're doing this obviously because we find more and more IOCs doing the same kind of thing. How can we look into the crystal ball and be ahead of the curve of this one? So trail of thought was, let's gather all the localhost domains on the internet. And then we're going to collect the whois data, all those, grep for name Silo, and monitor them for changes, which was a good idea. So I needed to make a little bit of POC on that. So Spice has 4.1 million records collected, historical. So why not use that? Because they have this really neat free filtering service. So You type in the register name silo in there, and okay, 645,000 domains. That's a bunch of them. Bear with me, they are not all the domains in the world registered by name silo, but these are the ones that at least Spice knows about. Then we can add another filter, which says, well, I want to look for the DNS record, that's 127.0.0.1, and we have now 373 records. That's a better number to work with. So at that stage, you're like, yay, 373, this is going to be easy breezy. But then you realize, damn it, they can just register a new domain. And that was historical data, so we need to be proactive in this. But fortunately, the Whois domain search releases daily all the records of all the domains that have been registered all the time. And it's everything from 50,000 to 250,000 domains on every day. So we started to get those daily, right? And then wrote a little crappy bash script here that what it did is that, you know, it went through the name silo file that we populated with all these new domains all the time. It went through a new, which is a 2-byte tom-nom-nom that just only worked on the things that were new, and the ones that we've been processes would end up in process, right? Did a Whois script for name silo, look for whatever goes on, and put that shit in sinkhole.txt. Run that with a cron job every day, and we collected all the data that we needed. Then have this continuously running other while loop where look for that, use DNSX by project discovery to make a really fast DNS lookup for that. Negative grep for the 127.0.0.1 because we know those, and we're extremely interested when things happen. So if that changes from 127.0.0.1, we want to get a little bit of that nice tick, tick, tick in our Slack channel that says that this has now left the sinkhole, so we can start to look into that. And we use Notify for that, which is also a tool where you can just pipe anything into it, and it's going to throw things in your Telegram or Slack channel or Discord or whatever. Let it sleep for a while, and continuously run. So that was a way for us to just monitor those and find the threat actor before they knew where the next phishing campaign was going to come from, because we had already been there and poked at the target and saw whatever went on.
Yeah, and I think it's a great example of the power that we have if we use threat intelligence right. And not all threat intelligence is useful threat intelligence, but some is. And so then the idea is how do we make this even better? How can we be even better prepared using threat intelligence? Because, just look at what's happening. Like, we live in a world where it kind of feels like they're kind of getting out of control. We all work in the business, so it doesn't maybe feel like this for some, but just look at some of the stuff that is happening. You got ransomware gangs doing supply chain attacks and mass deploying ransomwares to hundreds of organizations at once. You got criminals from these groups that take interviews with journalists and explain how their operations work, and they advertise their new affiliate programs. They actively try to recruit people in potential victim organizations and promise millions of dollars if they get them access to the internal network so they can do ransomware. They even call them. After they do ransomware, they call the victims and they threaten them on the phone if they don't pay. So they're getting bold for real. And they're getting organized, they're getting methodical, and they're definitely getting rich. They're getting very rich. Because cybercrime is thriving right now, and I just feel like we need to do something about it, which obviously we're all doing, but how can we do it even better? And I don't have all the right answers here. I don't know. I'm just thinking out loud, really. But I feel like if we just use concretely the stuff that we have every day, like all stuff that we know and that we can share, that can collectively help us to be more prepared. And I'm talking about sharing actionable threat intelligence, and it's something that we've been trying to do more and more the last couple of years. And but yeah, it's something that we need to do together, right? We need to come together and join the fight together, right? It is really a fight. At least that's how I feel about it. And together, as an industry and as a community. So using our understanding, our knowledge of the threats and everything that we see, putting that together, because that's a weapon we can use to just take the right decisions, because that's what it's about, right? If we take the right decisions, we do the things that actually matter. And that's how we can ensure that the job and the work that we do every day actually has a bigger impact. So we're always open to any type of collaboration, joint research, whatever. This is us. feel free to reach out. And thanks for listening.
Yay!
Thanks, awesome. I was just sitting there thinking, as like devil's advocate kind of stuff with the ransomware. This is, I mean, it's all fun and good, but this is all the stuff that you do while waiting for them to actually pay the ransom, right? They are going to pay the ransom. You're not.
I wouldn't say so. I wouldn't say so. I mean, now percentages varies because obviously people don't like to talk about that so much. But the companies we usually help, it's very, I mean, I don't have a number off the top of my head, but basically almost never pay the ransom. It's
publicly.
No, I mean, we work with them, so I can tell you. And it's about how, now, it's a hard thing to trying to find a good way to put it. Obviously, it's not nice to pay, right? Because you don't want to put that money into the criminal environment, right? Some companies just don't have any other way, so obviously they're definitely going to consider that. And there are companies that pay.
They are going to get worse and worse, like you're saying. They're going to call and threaten, it's where your kids go to school, stuff like that, until you pay.
Yeah, but I mean, if we're talking about ransomware, purely ransomware, right? So then it's about getting back to operations, right? If the systems are down, they can't work, then if you don't have backups, that's a much worse place to be. We've had several cases where the backups were really bad, but we had just enough for the very, very critical stuff that we could just take the important data, and then the rest you just rebuild, which is not always feasible, of course, but as much as we can, we do that, and we actually managed to succeed several times. And we also put it in perspective when we discuss with the customer, because obviously they're going to ask us, should we pay, should we not pay, is it actually going to work if we pay? And it might, but it might also not. And usually the actual key works. I mean, it's not something I would ever guarantee, of course, but technically or statistically, it works.
Business case.
Exactly. It's good for them to know or to let their victims know that if they pay, because the other victim paid and they actually got it back. So absolutely. But would you trust using your systems after that? You're still going to have to do a thorough recovery process and actually have to do forensics on each recovered system or decrypted system and all of that.
Understand me correctly. I think that we're heading into a direction where I'm worried that the customer that we're trying to help are not going to be on our side. They're going to say, can you fix it or do we have to pay? We need to know now. And that's just going to get worse.
I think the more we bring organizations back, the more we can show that we can help them without pain too.
Yeah.
And that, let's see if this mic works. And that actually leads to a next question from the audience, which is, like, in the case of a full domain compromise, how long does this investigation take? And when do you tell the client, okay, guys, we're good, let's go into production?
Again, it depends. There are two main, I guess it depends is the default answer for everything in security. But if it's ransomware or not ransomware, that's the main difference. Because if it's ransomware, you're already down. It's ransomware, okay. It depends if you have backups or not. That's another important question, right? Or at least if you have backups for your critical business systems. Then you can start working with those. And there are many components. I mean, some organizations have practical issues when you even need to ship computers to their different offices around the world, for example. You have all these issues. And those are usually the bottlenecks that you don't think beforehand. Even if you have thought about a disaster recovery plan, an instant response plan, there are these little things that always take longer than you think. Even if you have backups, we always ask, do you have backups? Yes. Even in the case that they actually have it offline, I hope more and more does nowadays, but if they do that, we ask them, have you tested them? And they say, yes. Okay, so how have you tested them? Well, from whatever backup solution is used, the testing is usually, can you bring back this folder from that date? Yes, test passed. That's not how ransomware recovery works. Ransomware recovery, you have maybe 100 of servers to bring back to a certain date at once. You're not going to even have the hardware for that. There's going to be bottlenecks that you need to take into account when you do the actual testing. So all that stuff comes up when it's already too late. So usually it's those type of bottlenecks that can take it all the way to 2, 3, even 4 weeks in worst cases. When we're lucky and everything works smooth, it can be a few days only. That answer the question? I forgot the question. I just went on a rant.
That was the question. How long does it normally take to recover after a ransomware?
I guess I answered that. Yeah. Okay. Cool.
And the other question that I got from the audience is like, after phishing, what is the second most common infection way for ransomware?
External vulnerability exploitation, known exploits, unpatched stuff on the internet. Definitely.
Patch your VPNs.
And everything else too. But especially, yeah.
If you put stuff on the internet, somebody's going to own it for you. If you don't own it yourself.
Yeah, I guess. Yeah. Sure.
So on fast example, you have shared a snippet of that malware, right?
Mm-hmm.
It is using curl. It is downloading using curl. But curl is not a binary of Windows operating system.
Yeah, in modern, the question is, the macro was using curl, but it's not a binary Windows. In the modern version, it is. You can call it by default. Yes, it works.
So, was it internal job? Because I have seen in the directory there was SSH directory in Windows folder, right? So
you're asking about the SSH directory in that snippet of Windows Explorer. That is unrelated to that case. That was just some folder to show what is Windows Explorer. So we know what we're talking about. It is not related to that attack.
Name silo, as per my knowledge goes, name silos give who is privacy for free.
Yeah.
So they prefer to buy from name silo.
You get privacy guard.
Yeah, privacy guard for free. So it is cheaper than any other domain name provider.
Yeah. So
if you connect domain silo with DigitalOcean together, shady stuff.
So you are on the way.
Yeah. Very cool.
And then we had some question regarding these RDP graph logs. Have you guys been in contact with Microsoft or asking them to actually maybe just publicly release how the hell they stitch this together?
that is a good point. We haven't done that. Worth a shot.
Because that could help a lot using it for forensics. I don't
Sure,
think
sure.
it's
Then people
ever
love to reverse stuff anyway, so maybe some will have fun anyways. But definitely worth a shot.
I have one more if it's actually relevant to that, which is the idea of you guys split off and said, okay, we saw this in the EDR that the client had, but this is where we went off the track. So I realized that, but the question is, of all the stuff that you had in terms of the rest of what you were mentioning, would you have caught that in most EDRs? Or in some of the really good EDRs?
I would say yes, that we would have caught it. Now, EDRs, if we were to recommend something as a type of product, I usually start with EDR because you can do a lot of stuff. You can have next-gen firewalls, you can have NDRs, you can have whatever. I think if you start looking into the endpoints, and by endpoints I mean clients and systems, that's eventually where stuff is going to happen, right? So I love starting with an EDR. Even if you have really crappy security, there is so many things you need to do, at least start having your eyes on things. It's a quick and very valuable thing to do. So that being said, it also depends how you use it, right? And there are many EDRs. Some are better than others. I think in general, they're great tools.
The first example I was thinking of was the timestamp on the registry.
The timestamp on the registry, well, I guess it depends how you do it, really. I think the actual action of the registry key edit or modified key event, I think most EDRs actually look at the registry in that way. And then it also depends how you do it, right? Because if you do it with PowerShell-C, registry load, whatever you call the function, then that maybe what's gonna trigger an alert, and then you look into it and realize what it did. But that's kind of, maybe you won't catch that particular thing. But if you have your eyes on everything that happens, eventually they're gonna step on a mine and raise an alert, right? I mean, in most cases, you can never be 100% sure, but I think that's a great start.
And it's also important to understand that not all these cases, they are not all connected, and they are definitely not all ransomware cases. Like we talked about before, how long does it take to detect? Well, we're having incidents where they have a system that actually monitors all this stuff, but if you're not looking at those logs and know what you're doing, then you're going to have a problem anyway. So that's going to be always a risk factor. You need to train your SOC people. Everybody needs to know what goes on. You need to be updated, and that's kind of how it works.
Which is easy to say, but
Yeah.
practice can be very hard, right? Because there are so many things you can possibly react to, so you need to choose. And that's where you can kind of integrate threat intel into it, right? If you try and think like, okay, we could potentially look at a million different things. What do we start with? Well, start with the things that are actually exploited in the wild now, right? I think that's the best place to start. If you can choose whatever, choose the ones that are actually a problem right now. There are a lot of others that we don't know about, right? The stealthy ones, the nation state stuff and whatever. And it's probably, let's consider the ones we know and work with those. It's a good start, I think. We need to be pragmatic. At least I like to be pragmatic.
Cool. And that actually leads to the last question from the audience, which comes to attribution again. Attribution is always hard, and you attributed this to Chinese nation state or Chinese ransomware gang. But what would the motivation be for the Chinese to run ransomware if it is nation state?
Those are not the same case. The case we were talking about, the nation state, was not a ransomware case.
That makes sense, because I think that needs...
I agree that would be unusual. Well, you can look at North Korea, I guess, but that's a bit of an exception.
Or some covert action where they're trying to pose as ransomware gangs while they're stealing information.
Yeah, no, exactly. But you don't usually have the motivation or the actual intent to do a ransomware for nation state. Yeah, you can have destructive.
There's no payment service.
I mean, there are Russian nation state actors who do destructive operations, right? That actually use ransomware that is not really ransomware; it's wiper malware. But that's destructive purposes, not ransomware.
And then that leads to do you see roughly, is there a percentage, how many of these serious attacks are ransomware? Is that a majority, or are you seeing more nation state ransomware, or like just rogue hackers in general in incident response? Yeah,
in general, the cybercrime side of things is definitely a lot bigger than nation state. Nation state is also, like you said, hard to attribute. So a lot of things goes in the uncategorized side of things. But definitely a lot of ransomware. That's definitely a big one. I think our own statistics from last year and half of this year is about half of all the incidents we've handled have ransomware. And they usually couple with data leak as well. So I guess they call it leakware these days. But you steal data and you do ransomware at the same time, and then you threaten to release the data if they don't pay for the key. So it's additional pressure. You had a question too?
Have either of you ever seen nation states use ransomware to cover their tracks or encourage misattribution?
The question is if we've seen a nation state using ransomware to cover the tracks. Well, specifically ransomware, I don't know. I mean, trying to put stuff there that looks like someone else, it's definitely something not uncommon. I can't think of a specific ransomware case, to be honest, right now. There might be, and I just can't think of it. Sorry.
Okay, final question from the audience. What's your recommended platforms for sharing threat intelligence, and how can you convince your organization to actually share threat intelligence with others?
I think platforms, there are a lot of platforms. It's just important to use the standards. So, Stix is a great standard. Mitre does definitions as well. So if we talk the same language, it's a lot easier to use information in a meaningful way. So use the big standards. It's, I guess, step number one. Then which platform, I guess it doesn't really matter in the end. As to convince the organization to share, that's a hard one. It depends on the organization, right? And also depends what you share and how you share it. I mean, you can take an email you got and share that, which will probably contain your own organization information, or you can have an internal process to wash that and then only provide the IOCs, because that's not your information. But that is more expensive internally to do, right? So if you can do that, that's ideal. But then you need to have resources for that.
Okay, thank you very much.
Thank you very much,
Thank
Fabio.
you.